Hi everyone who loves math and physics. My name is Mr. Ivan and today we'll talk about density. So density is a concept which is widely used in physics, in engineering, in astrophysics, wherever. When we want to optimize the mass of the constructions, when we want to calculate something about boats floating on the water surface. In many cases, we need density. And actually, it's a measure of mass concentration in a volume. The formula is very simple. It's denoted by the Greek letter rho. Density, rho, is equal to mass divided by volume. Very simple. The more mass in the same volume we have, the more density object has. Object or even substance, because various substances have different densities. Yeah? For example, if we have some kind of soccer ball is quite light and its density is not so huge. Its density is not so huge, of course. Otherwise, it would be kind of painful to kick it, yeah, for the soccer players. So this is our soccer ball, simply speaking. Its density is not quite big. If we take example of a glass of water, so the glass of water looks like it's even smaller than a soccer ball, yeah? But its density is quite higher. Water is quite dense substance, let's say like this. So a glass of water has higher density. Density grows. And if we have a golden ring or earring, let's say, okay, something like this, golden earring, it could be very small. Maybe I'm a bad designer, okay, something like this. It could be very small in the size, but its density is even higher. Its density is even higher because if we put same amount of gold into the glass of water as we have water in it, then surely that glass would weigh much heavier, okay? And if we have the golden soccer ball, then it would be really heavy and it would be painful to kick. So this kind of stuff we could say about density. The more mass we have in the volume, the more density object or substance has. Simple problems. Let's say we have a glass of water. How much does it weigh? How many kilos? Yeah. What's the mass of it? Usually, the volume of the glass of water is 200 milliliters. 200 milliliters, okay? Milliliter is 1,000th part of liter, or 1 millionth part of cubic meter, okay? So if we want to transfer it to cubic meters, we should multiply it by 10 to the negative 6th power, okay? Then it will be cubic meters. Okay. And then how much what is the density basically of water is 1,000 kilos, 1,000 kilo per cubic meter. Let's substitute those measures and calculate. So the mass of the glass of water would be rho density times volume, yeah? Okay, rho is 1,000. Let me write it in a way, 10 to the 3rd power, okay? Times 200 to the 10 to the negative 6th. I will not put here the measures. Obviously, we'll get kilos if we multiply kilos over cubic meters times cubic meters. Then what we'll get? 200 to the negative 3rd power, yeah? Which, as a result, would be 0.2 kilo, 200 grams or 0.2 kilos. That's the weight of a glass of water. Hopefully you understand it perfectly. Now let's take a look at a different problem, which is a bit more challenging. For that, I need this picture, which I hide it here. So I have now a ball which consists of 40% of volume of oak and 60% of volume of pine wood. What would be its average density? Okay, in order to calculate it, we have to know the total mass and the total volume. Even though we do not know the total volume, we just know percentage, still we can solve this problem. That's quite interesting. Let me take the basic formula into a frame like that and move it a bit upwards here. What do we need to solve this problem? We need to know the density of oak and we need to know the density of pine. So rho of oak, I would write rho sub O, okay, is equal to 650 kilos per cubic meter. And rho of pine, rho sub P, it would be, if it's dry, it would be even 400 kilo per cubic meter. Now, what we have to do, let's say that the whole volume is just V, okay? V is the total volume. Total volume means 0.4 V is the oak part, 0.4 V is the oak part, and 0.6 V is the pine part, yeah? Now, if so, we could calculate mass of the oak part and mass of the pine part. So mass of the oak part is the rho of oak, 650, times 0.4 V, okay? And mass of the pine part would be 400 is the density of the pine times 0.6 V, okay? Now, what can we say? We can say that total mass is our numerator, yeah, and just V is our denominator in the formula. Rho, average density, is equal to mass of the oak, 650 times 0.4 V plus 400 times 0.6 V over V. Obviously, now we could simply speaking cancel out those V, yeah, because it's common factor of the numerator, and same stuff we have in denominator. Now we can say that average density is 650 times 0.4 is 260 plus 400 times 0.6 is just 240. As a result, we have 500 kilo per cubic meter. That's basically it. It's average density of our oak pine ball, let's say. So that's how we can apply the formula. That's how we can solve the problems, and we can see how to deal with them in the future videos as well. For now, that's it. If you have any questions, please feel free to ask. If I didn't cover some part of the topics or some of your questions about it, please also write to me. I wish you all the best in your studies, of course, and see you soon. Bye bye.